How's it going, ladies and gentlemen? Mr. Downey here with some 10.9 problems. Real gases, deviations from ideal behavior. Turns out real gas is not perfect. All right. So an ideal gas differs from a real gas in that the molecules of an ideal gas have no attraction for one another. That is true for ideal gases. In reality, they do have an attraction for each other. Uh, Real gases have an appreciable molecular volumes. They're not, they take up space. Uh, so ideal gases have no attraction for each other, but real gases do. So you might have been thrown off by B because it's the opposite. It's saying real gases, this is true, but ideal gases, it's not. Wording, read carefully. Turkey 9. Real gases will behave most like an ideal gas under the conditions of blank. So you got to think about this. What does a gas want to do? Gas motivation? What's a gas want to do? It wants to spread out, and it wants to move fast. Right? That's a gas. They want to get out of here and they want to do it quick. So when would a molecule be most likely to spread out and move fast? Well, it's going to be when it has a high temperature, so it's moving fast, and low pressure, so there's not much resistance. It can spread out as much as it wants. 40. Which one of the following gases would deviate the least from an ideal gas? So we're talking about the most ideal. Most ideal. All right, well, we're looking for no attractive forces, which isn't possible. So we're looking for the least amount of attractive forces, which has to do with size too, right? If we have all nonpolar molecules, D sucks. Definitely not that one, because it's going to be a polar molecule, so it's going to have intermolecular attractive forces. So we're left with now nonpolar molecules. So which one's going to be the best? Well, you got to remember polarizability. The smaller the molecule, the weaker the attractive forces, the intermolecular attractive forces. All right, so we want the smallest one because it'll deviate the least. So which one of these things is the smallest? Neon has the smallest mass. 41. Van der Waals equation for real gases recognizes that gas particles have non-zero volumes and interact with each other. That is absolutely true. Let me stop there. Wait, no, don't. Molar volumes of gases of different types are different. That is a fact. There are different attractive forces between different kinds of gas. So if you had 1 mole of He versus 1 mole of xenon, they will actually take up different volumes because they have different attractive forces holding them closer. So they do have different volumes. The non-zero volumes of gas particles effectively decrease the amount of empty space between them. That's a fact, right? If we're looking at 2 molecules, there's less empty space in between them than if they were just 2 points, right? Because they actually take up space because they're real. The molecular attractions between particles of the gas decreases the pressure exerted by the gas. That is true. So if we were to take a look at like a container, so pressure is from the particles bouncing off the walls, right? And going and hitting it, and that's the pressure, right? Well, if they have attractive forces between each other, then that's going to slow them down because they're being pulled together instead of just being able to spread apart all crazy like. All right, 42. When gases are treated as real via use of the Van der Waals equation, the actual volume occupied by gas molecules blank the pressure. Let's think about this. Pressure is related to volume, right? So if we were to increase the volume, the pressure would go down, and vice versa. If we were to decrease the volume, pressure would go up. Well, let's think. Ideal gases, these particles are infinitely small and take up no space, but in reality, they take up space, which means that there is less volume for them to move around in, which means the pressure would go up. So the pressure is increased, and the attractive forces between the molecules blank the pressure. Well, let's think about it. Ideal gases have no attractive forces, so they can just go without any resistance. But these guys, if they're going to move away from each other, they have to break that attraction for each other. So it's going to decrease the pressure exerted. So which one is that? Choice C. I guess that's it. All right, that's chapter 10. See you in class. Bring questions. Ask me stuff. Test me. Do it.